For beginning linear algebra students, I'm going over 2 homework questions from the book Linear Algebra with Applications, which is an open educational resource. I will put the link below the video. Okay, find a vector equation. Don't solve. Well, I solved, just because I could. I took an augmented matrix, put it in Desmos, did RREF, reduced row echelon form, and I got answers. I could have changed them to fractions. Just didn't. However, to find a vector equation, we need to find vectors. So I just pull off the coefficients. x1 by itself means there is one x1. And you see how x1 is multiplied by this vector, and x2, x3, and then equals, which is the right column of the augmented matrix, becomes a 3-tuple equals 5, -6, and 9. Okay, when we have just a number or a variable that's just by itself, we move them to the right so we don't lose them, they don't get lost. And I was worried about this because when we're working with matrices, order is so important. But in this case, it's just a single potential number, so we can it's okay to move it in front. We can write them in other ways, which might make it easier to solve a problem. For instance, we can just say this is a vector column, we'll just call A1 times x1. You notice A1 is bold, x1 is not. Again for A2 and A3. It's just a shorter way of writing it. We just kind of squished the 1, -3, 5 down to vector column A1. And the same with the answer, it just simplifies to B. We could have also taken all 3 of these vectors right here and put them into a matrix, put the x1, x2, x3 in as well. And this is where a dot product comes in. You notice if we do the row times the column, we get x1 minus x2 plus x3. And then equals, and it will be 5. So that gives us, let me go back to the equation, x1 minus x2 plus x3 equals 5. We can get our equation right back. And then we can just say this is matrix A, vector B equals vector B. So the second problem, they did want you to solve it as if both homogeneous and not. Although if you just solve it with the reduced row echelon form, you can get both. So I put this into Desmos and came up with the following reduced row echelon form. Now we had 3 leading ones, so the only parameter we needed to have was x2. x2 equals 5, t. And x5 just equals a constant, x4 a constant, x3 a constant. It's okay, it can equal 0. We didn't really have to use this parameter at all, did we? There's just constants. Now x1 is a little bit trickier, but it's just, I throw in t for x2, and I now have a formula with a parameter, and then 3 constants. And I can put the answers in as a vector right here. So it'd be 5 rows, 1 column. And I can proceed to factor it, so I have constants and I have everything that was multiplied by t, which should be familiar from the video I did on basic solutions, because this is the general solution, but the particular one comes right here, and it just happens to be, what if t is 0? Well, this is a solution. And here we get the basic solution, where it can be just about anything we want. We can t equals 0, t equals 1, t equals 100, t equals pi. Okay, it's just, you notice how as a scalar or just one variable, it's out in front so we don't lose it. Okay, that was a couple questions from section 2.2.